All right, guys. All right, guys, this is the first video for chapter 3. Chapter 3 covers a wide range of topics with the primary overarching theme being the topic of ionic compounds. So for that, I'm just going to briefly remind you of a couple of things. Remember that compounds are pure substances that can be broken down further. They are not elements, but they are still pure substances, okay? They can be broken down further through chemical reactions, but they are still pure substances. And since they are made up of ions, in this case, ionic, let's just mention what ions are, which you've read about. Ions, of course, are charged particles, specifically charged atoms. Okay, and there are two classes of these. There are cations, which occur when the number of protons inside that nucleus are greater than the number of electrons outside that nucleus, meaning therefore that you have a positive overall charge. And this occurs from electron loss. And then you have anions, which are occurring when the number of protons inside that nucleus now are less than the number of electrons outside that nucleus. These are negatively charged, and these occur when the number of electrons increases. Therefore, this is a gain of electrons, okay? So, of course, the term ionization means you've had some electron transfer. What we mean initially when we say ionization, the most general idea of that is ion formation. And what this means is there's been a gain or loss of electrons, and you can only gain electrons when electrons are lost from somewhere else, okay? Good so far? Now, why do atoms want to lose electrons or gain electrons or undergo these processes to become ionic? Well, that has to do with the general idea of electron transfer, of course, and what it means to be a stable atom that doesn't generally ionize. Okay. Now, studying the elements, chemists discovered that there were one group. Remember, groups are the columns, the vertical families within the periodic table. They found that the group known as group 8 of the main groups, this means excluding the just completely ignoring the transition elements. So group 8, if you were counting across the top, ignoring the transition element, does not easily ionize. In fact, very difficult to ionize generally. These are your noble gases. Now, the reason that this appears to occur is because of one common property. All members of that family have generally 8 electrons in their what we call the valence shell. Now, if you've been doing your reading and studying your homework, you're familiar with the concept of the valence shell. Very briefly, you should review that and look into what a valence shell is. Just think of it in general, if you're struggling at all, as you remember those primary shells, the letter N, the primary quantum number. That is the outermost primary shell. Okay, if you were doing an electron configuration, as you would have been doing, and you've been practicing from our previous chapter, then say, for example, you were looking at the periodic table and you decided to look at an element such as, let's say, something like iodine. Okay, and you look at its electron configuration. We'll do shorthand here. Electron configuration for iodine would be krypton as the preceding level noble gas, and then going through that, krypton, then 5s2. We've got 5s2, 4d10, 4d10, and then 5p, 1, 2, 3, 4, 5, if you're counting across with me. So 5p5. Now looking at this, remember that these numbers right here, these represent the primary shell, okay, the primary quantum number. And the highest quantum number is 5, as you can see here, okay? And so in general, for valence electrons, we say that they are the outermost s and p electrons, okay? So for iodine, and in general for halogens, there are 7 valence electrons, okay? Now this is important because if you look at the periodic table, and let's go ahead and insert a periodic. So like I was saying, if we look at a periodic table, then you can see, looking at this periodic table, your halogens, of course, group 7. So here's group 7 right here. Let me make that with a laser pointer. So here's group 7. These are all going to have 7 valence electrons. We said here our noble gases have 8. That means, of course, everything oxygen and below oxygen has 6 valence electrons. Nitrogen will have 5 valence electrons. Carbon will start with 4 valence electrons. Boron will be 3 valence electrons. Beryllium will be 2 valence electrons, and hydrogen will be 1 valence electron. This is for neutral atoms. So what we can say here in general is, on this slide, for neutral atoms, not ions, but for neutral atoms in the primary group number, okay, so if we go primary group number 1, 2, 3, 4, 5, 6, 7, 8, if we look at the primary group number, that is equal to the number of valence electrons in that group for a neutral atom coming from that element. So any element in that group has that number of valence electrons. Important concept. Keep that in mind. Okay, we're going to stop this lecture here.